Good day, viewers. You are welcome. Here is an interesting complex equations. So let me just call it in that way. It's a complex equations where we have root I plus root minus I. I want to find the equivalent values for this. So let's try to consider from here. Suppose I consider from the first one, which is the root of I. So when I start this, I'm going to obtain this value separate and obtain this value separate. So when we recall that, we know that for every I, so it is given as square root of minus 1. Then, so we need root I, and here we have I, which is equals square root of minus 1. That is, we can also write this as I equals minus 1 raised to power of 1 divided by 2. So which is still the same because root here is just like the power of 1 over 2. Then suppose I take the power of this, which is I raise this one by 1 divided by 2. So definitely I'm going to raise the whole of this, which is having 1 over 2 already. Then we raise it by another power of 1 over 2. So on getting to this, so since 1 over 2 here can also be rewritten as root of I equals minus 1 raised to power of, so by rule of exponent, 1 will multiply 1, then we have 1 divided by, so 2 will multiply 2, which is 4. And we consider root I as minus 1 raised to power of 1 divided by 4. We have to note that in a complex space, anytime we have minus 1, this is equivalent to e to the power of I pi. So we have to replace this minus 1 with e to the power of I pi, as we have this as the square root of I is given as e to the power of I pi raised to power of 1 divided by 4. Then the whole of this one is equivalent to root I, which is e to the power of I pi divided by 4. And we consider this as the first one that we need. And also for the second time, we're still trying to get square root of minus I. So on getting this, then we couple the two together and we do the necessary substitutions. But how can we get the root of minus 1? So it's very simple. So we have to recall again from I square, which is given as minus 1. And here I square, we can write it as I multiplied by I, which is the same thing as I square. Then everything equals minus 1. Suppose I divide both sides by I. So when I divide both sides by I, so what we get here is I equals minus 1 divided by I. Then let's try to take the square root of both sides. Or before we take the square root, let's try to introduce negative here. So we have this as minus I equals minus into bracket of minus 1 divided by I. Then, so we have minus I equals minus multiplied by minus, we get 1 divided by I. Then we take the square root of both sides, as we have this as square root of minus I equals the square root of 1 divided by I. So having this, we have root minus I equals, so we can separate this as, so we have to split this and we get root 1 divided by root I. So for this root 1, we can consider it as 1 divided by the square root of I. But this square root of I, it has been gotten already, which is given as e to the power of I pi divided by 4. Then we do the replacement here as we get the root of minus I equals 1 divided by e to the power of I pi divided by 4. Then with this, we write this as e to the power of minus I pi divided by 4. And this is for the square root of minus I. So after getting these two, we have root I and we have root minus I. So the next thing we do here is we try to add the two together. So by adding this, we have root I plus root minus I. So this is equals to e to the power of I pi divided by 4 plus e to the power of minus I pi divided by 4. And also, for every e to the power of I pi divided by 4, when we consider the de Moivre's theorem, so e to the power of I pi divided by 4, we write it as cos of pi divided by 4 plus I sine pi divided by 4. Then plus again, so for this one, it comes with negative, as we have this as cos of minus pi divided by 4 plus I sine of minus pi divided by 4. So this equals cos. So for every pi, it gives us 180 divided by 4 plus. So here we have I sine minus pi divided by 4. For every sine is an odd function. So here and this one cancelled each other. And while for every cos, it is an even function, then we consider this as cos of, so minus go because it is even function, and also this is 180 divided by 4. So then this equals cos 180 divided by 4, that gives us 45, plus also this one is cos 45. So here we get cos 45 is square root of 2 divided by 2, plus also this one is square root of 2 divided by 2. And root 2 divided by 2 plus root 2 divided by 2, it gives us 2 open bracket root 2 divided by 2. So here by cancelling this, we get root 2. So which implies that for every square root of I plus square root of minus I, the result is root 2. We consider this as first method, and let's stay tuned for the second method, and it's going to be released tomorrow. Thanks for watching, and if you are new here to this channel and you find this video interesting, please do well to like, share and subscribe, and turn on the notification bell. See you in the next class. Never stop learning. Bye bye.